Greetings, universe! Hello everyone! Hope you are doing good. Hope you are properly hydrated. Today, what we're doing today? Well. Remember how last week we started creating some monsters? Well. Today then, we're going to carry on creating the monsters. But also, we will teach the monsters to move. Dun dun dun. Okay, let's get to it then. So as you can see on the screen, we have our monster blender kind of 3D model. Does it not look nice? Does it not look lovely? And we have some information about it in the inspector. For example, we have the collision shape 3D, which is this box that we see right over here. This is the box which takes care of the collision. So we're gonna adjust this just a little bit to make it make sense. I think this will be good for collision. Right. And aside from the collision, we probably want to do some more stuff to the enemy before we can actually get to the coding. Okay. So the next thing in the tutorial is to remove the monsters if they're not appearing on screen. So we will not render anything useless. We're going to spawn monsters at regular time intervals in the game level. If we're not careful, their count could increase to infinity, and we don't want that. Each mob instance has both a memory and a processing cost, and we don't want to pay for it when the mob is outside of the screen. Yep. Okay. So once the monster is not in the screen area, we don't need it anymore, so we should delete it. Godot has a node that detects when object leaves the screen, and it's called visible on screen notifier 3D. Okay. Let's check it out. Let's check it out. So, we have our mob and we have the character thingy. Now we have the collision shape. And now we want another node, which is called visible on screen notifier. A box-shaped region of 3D space that detects whether it is visible on screen. Ugh. So I guess we need to define the size of this. Okay. Okay. I suppose we will give it some buffer as such. Not enough buffering. Let's give it slightly more from the sides. Whoops. Let's give it slightly more from the sides. I guess it's this one. Yep, this is good. So, this box we see here is going to let us know when the enemy is outside the visible screen of the game. So when this box completely leaves the screen, the node will emit a signal. It will send a message to everyone. This guy is not in the screen anymore. Now, I suppose we can start coding. So, we will attach a script to the mob. That's what we're going to do. So we will call it mob.gd for GD script. Oh, hello Tank! How are you? Thank you for joining, welcome. Tank says, sorry I am slow joining today, especially for programming day. Oh, don't worry about it. I'm happy you're here. We are now... you're just in time for the actual programming. So there's that. Yay! Alright. So, basically what we did so far is implement a notification for ourselves for when the monsters is leaving the screen. So we will be able to delete it completely if it's not anywhere around. So it will not take some of our computation power if it's not on screen. Wait. Which is pretty much this type of node here. Okay. Now we will take care of the minimum speed and the maximum speed for the monster. And we want these properties, the maximum and the minimum, to be available on the inspector. So we add the export annotation. Minimum speed would be 10 and the maximum speed would be 18. Now, I'm guessing they're supposed to be available somewhere here. Probably. Actually, let's check the player. We have the speed parameter and the fall acceleration parameter annotated as export. Ah, there they are. They're here. Yeah, it means that the user interface also has access to these parameters. Ugh, that's kind of scary. If you're able to change parameters from the user interface, that can be very scary. Because then, even if you're trying to debug, you could never know that it's actually coming from the user interface rather than from the code. You're checking your code and everything is fine, and you're forgetting about the user interface. Ugh, I can see how tricky it can become in the future. I mean, at least this is a real problem that you have in Unity if you create those parameters visible from the user interface. So honestly, in Unity, I was trying not to expose any of those to be editable from the UI, because that can definitely cause some pain if you're not careful and if you don't remember how things go and where. Hello, Glimmer! How are you? Hope you're doing good. Thank you for joining. Glimmer says, hello, please no hate. Enemies only peace. Yeah, don't worry about it. Don't worry about it. We just have this guy over here. And he will try to beat our hero. Which is this guy over here. Yep, so this is our enemy. And you will create a physics process function. We will implement that one. Oh, hello, Kirby! Thank you for joining. Welcome. Kirby says SpaceC only wants destruction. No. This is the tutorial I'm following. I swear. Hello, nonsense. Welcome. How are you? Kirby, I swear. I come in peace. So, if you guys remember, there is a process function and there is a physics process function that we can implement in order to process stuff that happen on the screen for each frame. So these are like built-in functions that we actually need to implement them. I mean, we don't have to implement them, but you know, it's recommended if we want things to happen on screen. Kirby, I swear, this is just a tutorial. Yeah, this is what it's like. Jinx says, now I am seeing a giant SpaceC game where she walks around like Godzilla stomping things. Yes, I would be big. And then I will ruin things with my Godzilla hands and Godzilla legs. Like boosh, whoosh. Yes. And I will destroy everything in my way. Yes. Maybe we will create such game one day. Nonsense says, I'm okay, just had sore throat before my exam. Oh no! I hope you're better now. I hope you drank lots of tea. I am good! Thank you, Nonsense. Thank you for asking. Thank you. I'm happy you liked my voice acting. Right, so physics process, just a reminder, it's a function that we want to implement to let Godot know how to deal with our objects on the screen. And as far as I remember, it is being called every frame, which is going to be similar to the update function in Unity, which is called every frame. And then you basically tell the engine what to do in every frame of the game. So, physics process. It's called during the physics processing step of the main loop. Physics processing means that the frame rate is synced to the physics. The delta variable should be constant. delta is in seconds. It is only called if physics processing is enabled, which is done automatically if this method is overridden. And okay, that makes sense. And similarly, we're supposed to have just process, which is this one over here, if it's not related to physics. It's called during the processing step of the main loop. I guess main loop is like every frame. Processing happens at every frame and as fast as possible. So the delta time since the previous frame is not constant. This here is not constant, while here it should be constant. The delta variable should be constant. Okay, so for a physics process, it should be constant, and for a regular process, it should not be constant. Okay, so this one happens every frame. This one happens every delta. I think that makes sense. I think I'm getting it right. Right? Okay. So just like with our hero, we have a move and slide function, which we can use for the enemy as well. Move and slide is just free movement stuff that we get from Godot for free, because it's nice that it implements stuff for us. I do wonder though, if I want to update this function, I wonder if that would be possible. Moves the body. Is there a way for me to see how move and slide is implemented? Just in case I want to update the way it works. Interesting question. Let me check that. Let me check if this is something I can change. Let's see. Just gonna open a new window. For implementation. Okay, so I'm looking for move and slide, Godot for implementation, just to see if this is something we can somehow change ourselves. Change by ourselves. Where can I check the code example to see how it works? It should be open source, right? I see there is like a GitHub page which is called Godot Proposals. And it's talking about making use of the move and slide and user implemented controllers. Well, that's interesting. Okay, I will really have to look into the Godot engine repository itself. I'm in the repository. And I will just simply search for move and slide. Move and slide. Ah! It didn't find anything. That's strange. How come it didn't find anything? Okay, because it's just looking for file names. I guess I will have to fork the project and download it to my computer probably if I will want to make a better search here. I see some C++ code. I guess Godot was written in C++. Okay, means it will be a little bit tricky to see how this one was implemented. Okay, maybe I will take a look at some another time. Because I really have to take the repository to my computer and then look through it. Because through GitHub itself, it's not very convenient. So I'm just gonna leave it like that. Okay, how do we continue from here? Similarly to the player, we move the mob every frame by calling the function move and slide. This time we don't update the velocity every frame. We want the monster to move at a constant speed and leave the screen, even if it were to hit an obstacle. Okay. We need to define another function to calculate the velocity. This function will turn the monster towards the player and randomize both its angle of motion and its velocity. The function will take a start position, the mob spawn position that is, and the player position as the argument. Okay. Right, okay, let's go back to the script then. Now I will create an initialize function. We will need a start position, and player position. Okay. Guys, if you have any questions about whatever I do, please let me know and I will be very happy to explain. Okay, I see there is a function that is called look at from position. And it can look at the player. Okay, we will use look at from position. And we will give the start position, then the player position. The start position will be where the enemy spawns, while the player position will be where the monster will look at. And then we will have vector. Ooh. Hello, Ali. How are you, Ali? Thank you for joining. Welcome. What we're currently doing is we're making a game which looks like that. And so far, we can move the character using the arrow keys. That's cute, right? And now we're going to spawn some enemies for our character to be challenged. So yeah, let's check what the look at from positioning function does. It moves the node to the specified position. Okay, this is our spawning place. And then it rotates the nodes to the point towards the target, which is our character. Ali says, sorry for not joining for long. I was getting ready for a district or the Olympics. Oh, is it the English Olympics that you were practicing for? How is it going? I hope you're doing good. I'm happy you were able to join now. Okay, and now we will use rotate Y. Which is like the random rotation that we wanted to add to the character. We will rotate the monster randomly within the range of like minus 45 degrees and plus 45 degrees. So that the monster won't move directly towards the player. But just in a random way. Hello, 04 Kilo. Thank you for joining. How are you? Hope you're doing good. So we're taking the range of minus 45 degrees and plus 45 degrees. Which is going to be like so. And like so. It seems like we have an error here. Why do we have an error here? Because the function isn't right. We need a range. There we go. 04 Kilo says, I'm pretty good just hunting legendary animals in Red Dead Redemption 2. Ooh, okay, that's nice. Good luck with that. I am currently making a game from a tutorial for Godot. This is our lovely character. We are scripting its movement. I mean, we have already done that. And now we are adding some enemies. So we have done the script for the player. This is our player. Our player looks like that. And this is the enemy. The enemy looks like so. So this was the code for the player. And this is the code that we started to write for the enemy. As you can see, for the player, we only have the physics process function so far. Which is called every X time and every delta seconds. And delta is supposed to be like a small number. But a constant one, that for sure. Okay, let's go back to the enemy. So we got a random position. Now we need a random speed. We will use Ali says, I mean, I didn't get the name. The name of what? I'm not sure what you're referring to. But Ali, I also asked you about your Olympics preparation. How are they going? Oh, you say it's good. Yay! That's nice. I'm happy it's doing good. But Ali, I don't really understand your question. Please explain. Okay, so let's continue with the initialize function to add the speed of the monster. Ali says that it reminds of Dark Bowser design. Ah, I see. Well, it's supposed to be like the blender. It's supposed to be like the blender mascot symbol, but just a dark version of it. This is like the good version, and this is like the bad version, the mini version, the evil one. Okay, so now we will create a new variable which will be random speed. And we will get a random number between minimum speed, which we defined over here, and maximum speed, which we also defined over here. Yeah, so this is what we're gonna have so far. And now we will need to calculate the velocity based on random speed. So the velocity will be a vector, a three-dimensional vector forward, which is already like the direction that the enemy is already facing. And now we will multiply it by the random speed that we just calculated. Let's do that. And now we also want to rotate. I mean, to give it the direction too. Okay, so we rotate the velocity vector based on the monster's y rotation. Yeah, in order to move into the direction where the monster is looking at. Okay. So we will do it like so. Velocity dot rotated vector 3 dot up, and rotation would be y. So by saying rotation y, we're defining where the monster will look at and where the monster will move. It will be the angle where the monster will go. So I guess the forward doesn't really mean where it's going to go, it's just forward. Let's see what it means. Oh, okay. Forward unit vector represents the local direction of forward and the global direction of north. Oh, okay, so it's just a random way to say a certain type of direction, which just doesn't matter which. Like we could use either forward or back. It didn't really matter, I think. We could have used either forward or back because anyway, we're taking rotation Y. Oh, but as I saw, we also have the model left, right, and front and stuff. Unit vector pointing towards the front side of the imported 3D asset. Okay. So this is in comparison to the model itself, while all of these are the global direction of either north, south, west, or east. Ali says, well, I think the player must have a weapon to defend himself. We can maybe add that later. For now, I want the monster to move. But I think you're right. After we make the monster move, we will need the player to let the player somehow protect themselves from the enemy. We will do that after we implement the enemy. Tink says make him breakdance. I am not very good at 3D animation, but I am willing to try. Okay, so this is how we initialize the enemy. But now we have to destroy it whenever it's leaving the screen. Yes, Jink, we have to make it move. That's a first here, for sure. I agree. Okay, so we still have to destroy the monsters when they leave the screen. And to do that, we need to take the visible on-screen notifier, this node over here, and actually capture the signal. So we will go here. We will select the node. And then then it seems like we have something here. Ooh, there are signals. Okay. And we have under visible on screen notifier 3D, we have screen exited. Oh, okay. Ooh, we're able to connect a script or a whole node, actually. I'm worried that it's possible to do through the UI. Okay. I am very worried about all sorts of configurations that are done through the UI. Ugh. Oh, hello. Yay. Thank you for the follow, Kiki. I really appreciate it. Thank you so much for joining. How are you doing? I hope you're doing good. I I am currently working on a tutorial game for Godot. Let me show you what we have so far. This is our scene. And we're able to move the player around. And now we're working on some enemies for the player to defeat. This is our enemy. And now we're working on ways to destroy the enemy. Yes, Bucky. I mean, Ollie. This is how we're going to follow the player, because we're going to get the player position. We're going to get the player position, and we're going to look at the player to decide how to get to their place. Yes, Ali. We will him or her, depending on the player. So we have connected the notification, the signal that is. We made a connection from the signal to the code, and currently I'm very worried about the fact that it's done through the user interface. I don't like it when things are being done through the user interface. I hope there is a way to connect signals through code. I wonder if that's an option for Godot. Let's look it up. Godot for connect signal programmatically. I don't see a straight answer here. I just found the documentation about using signals. But it's yet again stuff that are happening through the user interface. I hope. I mean, let's see if we just add this function. Is this going to be updated? How are we going to disconnect those? I mean, let's just do that and see if the connection happens if we just pass this function as so. It does not look like it have an effect of any sort. This. So it looks like we have to do this through the user interface. I don't like it. This can cause so much trouble. In Unity, you're able to connect stuff like that from code alone. I hope there's also a way to do it from code alone in Godot. I just don't know how to do it just yet. So I guess for now, we will do it through the UI. This is going to be scary to debug in the future. I guess this is another reason why it's good that we have the IDE inside the engine itself. because then we have all of those stuff on the side, and they're a little bit harder to miss this way. But I still don't like the fact that we're doing it through the UI. Oh well. Okay, so now we will call Q3 function. Our monster is ready to enter the game. Okay, so that's good. This function will destroy the enemy if it's outside of the screen. Basically, we have the signal, screen exit, and if screen exit happens, then it's going to be connected to this function. And we have this sign here, which makes the connection between the two. Alright. I guess now we can spawn the monster into the game. Dun dun dun. Okay. Ali says, help me, I'm having no ping. Why is that? No, your internet connection. No. Ali, I'm sorry. I don't know how to help you. My internet connection is not the best either. I don't know how to help you. I'm sorry. I'm sorry, Ali. Okay, we will update this to be 720. For this to be 540. Dum dum dum. Let's check it out now. Okay, now this is very small screen. Okay. Right, so in 3D, it's a bit more complicated to draw a path to make the enemy follow the player. We want to be around the game view so monsters appear right outside of the screen. Okay. But if we draw a path, we won't see it from the camera preview. Yes. To find the view's limits, we can use some placeholder meshes. The viewport should still be split into two parts. Yes, it is split. Okay, we need the camera, which is this one here. Okay, we have it here. Okay, so far so good. Now we will add some placeholders to define the area. Okay. So we will add a new child node. It's just going to be a regular one. Just going to be a regular node. And we will call it cylinders. They will be our barriers. And now, inside, we will take a mesh instance. And we will control the shape of the mesh. We will take the new cylinder mesh. Ali says bad connection. Oh, I'm sorry. Thank you for being around, though. Now I guess we will need to move the cylinder around to make borders to the map of the playable area, I suppose. Okay, where is the menu to see the top view? How can I change this to top view? Ah, there it is. Okay. And now I will move it back. And we will use snapping tool. The tutorial says as follows. You now want to move the cylinder along the ground plane, looking at the camera preview in the bottom viewport. It's recommended to use the grid snap to do so. Okay. And now we need to move it outside of the camera's view in the top left corner. Huh? Okay. I guess... Wait. For this preview, it's a little bit tougher to check it out because it's like I cannot see where it's ended, where it's beginning. I will assume it's somewhere here. Maybe. I don't know. I guess I will also use the top view perspective for the game too. For the camera itself as well. This part is very confusing. Because, like, I can't look upwards. Okay, there I can now. Wait, where's the preview box? I had a cool preview box before. How do I bring it back? Let's see. Guess I need to bring in the camera and do this. Oh, hello, welcome back, Ali. How's your internet? Okay, so what? I'm moving the camera now. Okay. So I guess I need to move the cylinder in a way that will not appear on the camera. I guess. Guess that would do. Ali, is your internet better? Ah, okay. And did it work for you? Did it work? Okay, I suppose now I will duplicate the mesh and bring it somewhere here. One, two, three, four. Now we will take these two and also duplicate them and place the cylinders. Also, 1, 2, 3, 4. Like so. Hopefully the snapping worked. Yeah, it looks okay. We see the cylinders in the corners. So that's good, that's good. I think it works okay now. At least it's just some offs and ons helps. Yeah, the good old restart. Okay, I guess now we will change their colors so they will be a little bit easier to see. So in the inspector, we'll go into the material. Where's the material? Oh, there it is. There's the material. We will take this one. And now... what can we change about the material, I wonder? I guess we can change the color. Which color will we take? Guess we will take something like this. Yeah, that will do. Now we can see those a little bit better. Okay. Okay, now we can use these cylinders as our guides of where is outside of the screen. Because if we will take, for example, this one and we will move it here. Oh, we don't see it. But now we see it. So I guess this is the edge. But I will snap it to the grid so it will be nicer. Ali says I have to sleep. No worries, no worries. Thank you for joining today. I really appreciate it. See you tomorrow. Okay, now we will add another child. This time it will be called path 3D. Ali says because I am go to Oscaman early at age. Oh, no problem, no problem. Good luck, good luck. Okay, so the tutorial says as follows. Click in the center of each cylinder to create a point. Then click the close curve icon in the toolbar to close the path. If any point is a bit off, you can click and drag it to reposition it. Okay. Let's give it a try then. Ah, this is completely off. And now we will close the points together as follows. No, we will need to add one last point, I think. No, doesn't work like that. We'll use this and then this. There we go. Ugh. No. Why is it creating more points? Ah, because I'm still standing on that one. Okay. Like so. And wait, we have to turn it off. Okay. Ugh. Whoop. Interesting. Okay, that's good enough, I suppose. I don't wanna spend time centering all of that. To sample random position inside of this square, we need a path follow 3D node. Okay. Okay, so we will add another node over here, which will be called path follow 3D. Okay, so this will be called spawn path, and this one will be called spawn location. We have a lot of errors here because we changed the name. Weird. Okay, now we have a script for the main scene. Dun 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 dun. And now we need to add an export for the mob scene, so we can attach it so they will know one another. Showing things off from the inspector again. From the UI again. Again, I don't like it. But, you know, we have this IDE part of the engine, so I guess that's fine. So we want to spawn the monsters at a regular time interval. To do this, we need to go back to the scene and add a timer. But before that, we need to assign the mob scene file to the mob scene property. Otherwise, it will be empty. Okay, so let's go back to the 3D view. And we will need to attach a new scene here. Which will be... Where is it? Where's the mob scene? Oh, there it is. I guess we will drag it here. And I really, really hope there is a way to do this programmatically. Ah! Okay, now we add a new node of type timer. There are so many types of nodes. That's pretty cool. That's pretty cool. We'll call it mob timer. Okay. Now we have all sorts of parameters related to it. Change the wait time to 0.5 seconds and auto start will be on. If we hit auto start on, it means that it will automatically start whenever the game is running. Timers emit a timeout signal every time they reach the end of their wait time. So we will have a signal being fired every 0.5 seconds. And it will restart automatically. Yeah, we can connect to the signal from the main node spawn monster every half a second. Okay, it means that in here we have this one here. This is a signal and we want to connect it. What do I want to connect it to? I guess to the main node. Okay, now we will be able to update this function right here. So first and foremost, we will take a monster from mob scene. And we will instantiate it, which means we will create it somewhere on the screen. Now we need to identify the monster location where we want it to be spawned. Mob spawn location. Get node. Spawn path. Spawn Okay, so it means we're actually interested in getting this one. So at least this is okay. This is similar to the get component, I guess, in Unity, and this is like a way to get one of those instances, one of those nodes that appear on the scene. They're not declared in the scope. What? Oh, of course, because I didn't. I'm supposed to do this. Of course, of course. There we go. Now it's better. Okay, so using get node, we're able to access all sorts of nodes. Good, good. That's good. But again, I'm not sure I like this one. This is going to cause a lot of trouble at some point. We will need to debug stuff. That's for sure. Dun dun dun. Okay. So now I need to give it some kind of an offset. Location. Dot progress ratio. Random float. Mob spawn location. What's the progress ratio, I wonder? What's this? What's the progress ratio? I don't know. What does it return? It returns a note. And now in this page we're supposed to find progress ratio. There's no such thing as progress ratio in the documentation here. That's pretty weird. That's pretty weird. I don't know what it does. But I guess it's just a random number inside the zone that we defined. Okay, now we will get the player position for the monster. Player.position. The $sign. If I remember correct, the $sign is about referring to a specific node. Now we need mob.initialize. Mob spawn location dot position. And we send the player position. I'm not sure I like that this is happening in the scene logic itself. This is coupling the player code and the monster code together. I mean, of course we need to couple them, but we're also coupling all together with the scene code as well. What if we will have another level? How can we replicate this logic towards there without replicating the code? This tutorial, I hope this is not a good practice, and I hope this is just to show the general tools that are being featured in Godot. I really hope this is not how you're expected to write code in Godot. Because I would not put this type of logic in here. I have dependencies not just on the player and the monster, but also on the scene of the level. I don't like it. Why would the person that designed Godot let you do that? In their tutorial, more than anything. In their official tutorial. This is not good. I don't like it. Ugh. Okay. Anyway, we will add the child, the new child that we created, to the scene. Okay, so this one produces a number between 0 and 1, which is what the path follow node progress ratio expects. 0 is the start of the path, 1 is the end of the path. The path we have set is around the camera's viewport. So any random value between 0 and 1 is a random position alongside the edges of the viewport. Oh. So that's what the progress ratio is about. Okay. I see now. Well, let's check the game now. Ooh. Okay, whenever they are being touched by the player, they stop. They're piling up. It's not just when they touch me, but also when they touch another enemy too. Hehe. They keep on piling up. They keep on piling. Help. Help. They keep on piling. They keep on piling. I will hide here. Yes. Good idea. Okay, I think I'm stuck. Oh, I'm not stuck. Oh no. Okay. I am safe here from the enemies. I am safe. Dum da dum da da dum da dum da dum. Yeah. Okay. This is getting ridiculous. Okay, I'm stopping the game for now. Okay. So what we have so far is enemies that if they touch one another, they stop. Or if they touch me, they also stop. Ah! But, oops. If they don't touch anything, then they die. No. Okay. Okay. A new interesting pattern happening here. Unlike before. Okay. Now is our ability to protect ourselves going to be implemented. So now we will implement the squash, the jump and squash. In this part, we will add the ability to jump and squash the monsters. We will make the player die when a monster hits them on the ground. Dun dun dun! First, we have to change settings related to physics interactions. Okay, now we will take care of colliders in physics and stuff. Physics bodies have access to two complementary properties: layers and masks. Layers define on which physics layers an object is. Masks control the layers that body will listen to and detect. This affects collision detection. When you want two bodies to interact, you need at least one to have a mask corresponding to the other. Okay, so masks, they control the layers that a body will listen to and detect. Okay. So the important point is that you can use layers and masks to filter physics interactions, control performance, and remove the need for extra conditions in your code. Oh no! Does it mean that we need to place more things on the UI? Oh no. Oh no. By default, all physics bodies and areas are set to both layer and mask 1. This means they will all collide with each other. Physics layers are represented by numbers, but we can give them names to keep track of what's what. Okay, let's set the layers names. There we go, layers names. And 3D physics. This is the one we need. So let's have one layer for the player, one layer for the enemies, and one layer for the world. Now we can assign them to our physics nodes. What's this gonna do? Oh, I removed it. I did not mean to. Okay. Now we have names for 3 layers. Okay, let's go to the main scene and check out the inspector. And we're supposed to have layers for collision. There, this is our ground. And we have a collision object. There it is. Okay. 1 and 1 will be related to the player, that's all, right? Okay, actually, we decided that the world is layer 3, so we will put it over here. Let's see if it's... Yes, it's identifying the name world that we gave it. Okay, that's good. The mask property, which is like this grid that we see here, allows a node to listen to interactions with other physics objects, but we don't need it to have collisions. Ground doesn't need to listen to anything, it's just there to prevent creatures from falling. Okay. Okay. Let's carry on to the player. Let's check out the collision again. Well, actually, we need to go to the player scene. Okay, this is the player scene. Okay, let's check out the collision. It's under the character 3D body. Now, the character player should be 1. And the player should care about enemies and the world. Now, we need to go to the monster. And for the monster... Wait, did we do the right thing? Yes. Here for the monster, we'll do like so. And the monsters are layer 2. And about the mask, not sure what to do about the mask. Let's see what the tutorial says about the mask. These settings mean the monsters will move through one another. Yes. If you want the monsters to collide with and slide against each other, turn on the enemy's mask. No, we don't want that. But do we want the monsters to go through the player as well? I guess not. But I guess also the enemies should care about the ground. I think. I'm still not sure about what the mask does. So we'll see. as we carry on. Okay, now let's give our player the ability to jump. The jumping mechanic itself requires only 2 lines of code. Oh, impressive. We need a value to control the jump strength and update physics process, which is this one. Okay. So we will continue here. Well, let's handle jumping. Adding a comment here. Expert work jump. Impulse. Hi. Galoy. Galoy. Do you mean hello? Is that what you mean? Oh, okay. So expert only has to be like a global variable, I guess. Да. Так. Что случилось? Okay. F is on floor. And input is action. Just pressed. Action just pressed. Jump. We change the velocity of Y to make the character jump. Target velocity dot Y. Jump impulse. Ah, that's all. Well, that's nice. Okay, let's see what it looks like to run the game now. I can jump. Boop 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 boop. Bum ba-dum ba-dum. Bum ba-dum ba-dum. Dum ba-dum 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 ba-dum. Bloomer says, "How are you, my little spacish friend?" I am good. I am good. How are you? I am currently jumping around, jumping around. Jumpy, jumpy, jump. Jumpy, jumpy, jump. Jumpy, 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 jump. Yes, it is great to jump. Okay. Now we need to enable the squashing mechanic. So we're going to make the character bounce over the monsters and kill them at the same time. Dum, dum, dum. You are very what? We are preparing the game. So far, we're able to move in all sorts of directions. And we're also able to jump. Jumpy, jumpy, jump. Jumpy, jumpy, jump. But now we're also adding the ability to squash our enemies. Roar! Yes, squash. I am Squashing enemies with code. So basically, we need to detect collisions with the monsters and differentiate them from collisions with the floor. To do that, we can use tagging. Glimmer says, cool, you make a 3D Mario. Yes, kinda. Just like you can squash stuff in Mario. I guess this is a little bit similar in that way. Okay, let's go to the enemy. This is our enemy. Pineapple on pizza. Do you like that? Okay. So now I need to create another group. I'm not sure I like the idea of groups. Glimmer asks, do you like a pineapple pizza? I don't know. I mean, it looks nice. But I'm not able to taste it to say if it's good or not. I just know that humans really like arguing about it. Okay, I'm not sure I like the idea of groups. It will make the game search every time for whether the object is part of a group or not. I'm not sure I like this. But maybe it's not... Maybe it doesn't cost too much to make this check every time. Maybe maybe it's implemented in like a good way. I don't know. Maybe it's okay. Okay, let's carry on with the guide. Glimmer says, be cool if enemy was pizza and you would be the pineapple. Yes, exactly. This is what it would look like. Yep. Okay. So I created the group that is called mob, and now I will add this node to the group. How do I add it to the group? I guess it was automatically added because I added it here. E. We can use the group from the code to distinguish collisions with monsters from collisions with the floor. Again, so many things are defined in the user interface instead of the code. I will really have to check if this was possible to update programmatically instead of the user interface. It's very worrying for me at the moment, I have to admit. Okay. Now we're going to code the squashing mechanic. At the top of the script, we need another property which is called bounce impulse. Bounce. Bounce, 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 bounce. There we go. After the jumping code block, we added a buff. Glimmer says, я не могу говорить английский и русский, но мой хотеть сказать, что прекрасно игра выглядит. Thank you. Glimmer says that the game looks nice. И очень хорошо для начинания желать тебе успех и процветание. Thank you so much. Thank you so much. Yay. Glimmer basically wishes me luck with my game. And says that it looks nice so far. Thank you for the kind words, Glimmer. Thanks, sis. As it's a tutorial, perhaps they are just presenting the easy introductory way to do things with the more standard advanced way being in the code. Yeah, I hope you're right. I really hope you are right, Hank. I will probably check this in between streams or maybe in the next stream to see how this type of stuff can be defined through the actual code, because this is a lot of things here depend on the UI and it's scary. Glimmer asks, what's your favorite anime? I will start to watch anime in Ukrainian. I want to see more anime. Please help me. Дякую. My favorite anime. I don't have a favorite anime. But I guess one of the most influential ones on me would be probably Kado Captor Sakura. What about you? Okay, so we have the bounce impulse here. Now we need to detect collisions and take care of them inside the physics. Okay, so as I said, one of the most influential anime is Kado Captor Sakura. But it's like a classical Maho shoujo. Another one that I like is probably Madoka Magica. Hmm. Well, if you want some recommendations, then I've heard that Attack on Titan is supposed to be pretty good. But quite violent, I would say. Not for the faint of heart, as far as I know. But I've heard it's good. Also, I have heard that Full Metal Alchemist also is good. Okay, now we need to iterate through all collisions that occurred in the frame. Oh no. Iterations every second. For I in range. Get. I can't believe we're going to iterate through all of the collisions. Blah, blah, blah. Well, I guess it's not so bad. If we're keeping all of those in context anyway, in the context of Godot, then I guess that makes sense. If collision dot get collider is no, then continue. Oh no, what is this? Why the tutorial tells me to do something like this? No! This is horrible. Why would you add continue inside a for loop? No. Glimmer says, please put it into text. I can't hear the name. Okay, so these are not really my recommendations per se, but I've just heard that these are good ones. I've heard these are good. Attack on Titan, Full Metal Alchemists. There. Now you have them. Now you have them. But I'm not sure they are for like your average kid. If you're not an adult, then maybe this is not quite for you. I don't know. Sure. I don't like this. Why would you use continue? The person who created GD script, why would you allow your developers write this type of word? Why? This is not a good idea. This is how you create spaghetti out of code. If collision dot get collider is in group mob This is not the way to do this. We will have to do it like so. I prefer it this way. And I am removing this. This is disgusting. I'm just going to do like so instead. Glimmer, no. No, no, no. Please, no. Okay. Collision. Get collider again. We're getting the collider again. Ah, this was horrible. No. We're duplicating so much code in here. That's not good. That's not good at all. Let's just do var collider and put it in a variable. Kirby, why? Why are you reacting like that? Kirby, let me show you what the game looks like so far. I think you will like it. I think you will like it. Do you want to see how the game looks now? What the game looks like so far? What do you want to see? Okay, that's better. And now, if vector dot up. Kirby says coding is tedious. Something is always wrong. Well. Things can go wrong even in art stuff too. So, you know, it can happen anywhere. Not just in coding. Collision. Get normal. And check if it's above 1.0. If yes, mob.squash, but we didn't implement it yet. Squash the mob, but we didn't implement it yet as far as we know. And target velocity dot y equals bounce impulse. Huh. Did I not write it correct? Well, squash data doesn't exist yet. Wait, what was the difference? Get normal. Oh. Okay. Now it's good, now it's good. Okay. So, this one is not going to be possible just yet because we didn't implement it. But, Kirby, let me show you what the game looks like so far. Look, we can jump. We can jump. Whee! Jumpy, 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 jump. Jumpy, jumpy, jump. Jumpy, 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 jump. Whee! Whee! Doesn't it look fun? Isn't it great? Don't you think? Boop! We bounce on them. We bounce on their heads. Boop, 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 boop. Doesn't it look great? Boop, 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 boop. Okay, let's implement the squash. We will go to the mob script. And then we will create the function squash that we're calling from the player. Squash.emit. We're sending a signal here, I think. Funk. And Q3, which is a destroy. Now, what does it mean? I guess it means that we are creating a new signal. Just here, signal squashed. We're sending it to everyone to know that the enemy got squashed. Dum dum dum. I guess it's so it will be possible to update the score. Boop. 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 Wait, that did not work. Boop. 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 Well, that's fun. Boop. 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 Isn't that great? Boop. Ah. Boop. 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 No. Wrong boop. 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 Yes. So the game looks kind of nice so far, don't you think? We're booping the enemies. Boop. 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 Squashing the enemies. Squashing the enemies. Boop, boop. Boop. Coding is nice indeed. Woohoo! Yeah. So what we have to do here is to go through all of the potential colliders. And then, when we're getting one of them, we're checking if it's part of the monsters group. I feel like this check is kind of expensive, which is why I don't like the grouping, but okay. And then we're checking if we're in the air, and if yes, then we're squashing and making a small bounce. Do you guys have any questions about this? If yes, feel free to join our Discord, where we chat about all sorts of stuff related to game dev and art as well. Yep, so feel free to join if you would like. And aside from that, I think we are done for today. So, thank you guys for joining me.
have a very lovely, lovely, lovely rest of your day.